designed this thing on a napkin in a very basic concept in a restaurant. So, what do we have here? And this is, okay, we used to have like 6 models. We had 1500, 1800, the 2000, 3000, 4000, and then the century model, okay? And the difference between all the models is one was a basic skeleton, spin grind only, basic skeleton frame, spin and relief grind, and then the 2000 was spin and relief, the 3000 had automatic infeed, the 4000 had spin and relief auto.
Express Dual is probably our main competition, made in England. They're using old technology that one of our first grinders that we ever designed is still manufactured the same basic concept. There's a spinning, like the Neary. The Neary over here is what we call a spinning shaft. It's got a sliding hub and dual end infeed. So basically what you're doing is putting the cutting unit, and all of these are like that, you put the cutting unit on the table and you take, and your setup is you move the cutting unit to match the travel of stone, or the cutting unit is stationary, and you the stone travels stationary, not stationary, but in a single plane, and then you move the cutting unit, or you move the grinding head travel to match the reel. So,
which we have that purple.
yeah,
That's
that's that one. This is single blade relief grinder, we call it. It's all, that was the staple of the industry for many years. Pros and cons, did a hell of a job, put a lot of relief on there, but you had one guy had to stand there and go back and forth all day long. The single blade grinder, okay, have you talked about land areas and relief? Okay. The old staple, the old method would be to measure off the center shaft. So the cutting unit is
on this side of you.
yeah. Okay. Cutting unit sits in there, and it's called a suspension grinder, and we go off they measure off the center shaft, in and out, and up and down, to hopefully square up the cutting unit, I talked center line reel shaft, to the travel of the stone. Travel of stone is basically the fixed point. Okay. And what the old school was, do just relief grind, bring that reel to a point, grind your bed knife, put the two together, and lap the land area in. I don't know if George has covered that. Okay, that's pretty time consuming. Then Express Dual came into the market, the tabletop spin grinder. Now we're spinning the reel, and hopefully we're going to make it sharp, but that's all we're going to do. So, okay. Let me get my thoughts back together, and what we're going to do is we've morphed to this. Nowadays, in today's market, we make one grinder. It's a tabletop spin grinder, and then we add options and accessories to it. This is as close to grinding on a bench plate or surface plate as you can get. The way we make this table is 3/8 plate welded steel, so it's just a hunk of steel. It's solid. There is absolutely no flex in there. Once we weld the table together, we jig it up, put it on a huge boring mill, and we mill these surfaces as parallel as we can get. And that's a large area to mill off. Once we mill that, okay, the old days we used to mill this, and we used this, 90 degrees, and that was how we set the reel up. Magnetic base, dial indicator, and so we would align the cutting unit in and out and up and down. The problem with going off the center shaft when you line it up and down and in and out. If you've ever used one of those, you can use a dial indicator, and the whole point is go to the center shaft of the reel, go to the center shaft of the reel, zero your indicator out, okay, move your dial indicator to the other side, and try to go to the same blade, follow the same blade, and then measure and zero, and bring it in or out to zero it out. Problem is, you turn the reel 90 degrees and you get a different reading. That center shaft of the reel has been, it's non-machined, it's painted on, it's welded on, so it's distorted. The only true, if you know anything about machining, guys want to go off a machined surface to set stuff parallel, perpendicular. So that's not going to work. I mean, it works. It worked for years. We used to do it. It's close, but the accuracy is within 0.15 of an inch. So, and when I say 15, you may do a bunch of reels, and one reel will be cylindrical within 1,000th inch, 1,000th of an inch. Next one will be 5,000. Next one will be. Just keeps going on. There's no uniformity. There's your pipe tape. You have a pipe tape here?
Right there by Ethan.
Oh, okay. All right.
Grab the pipe tape.
Good. So anyway.
They're on by magnetic, so don't.
So anyway, we'll bring it back full circle and we'll talk about what we're doing here. As far as reels goes, there's 5 things we want to do to a reel when we sharpen it. Number 1 is, any ideas? Sharpen it. We're going to sharpen that reel. Second thing we're going to do is we are going to take any cone out of that reel and bring it back to a cylinder. Third thing we want to do when we grind.
Take the burrs off.
Pardon?
Take the burrs off.
The birds?
Burrs.
Oh. We do that. Actually, when we grind it, we're going to put a burr on that edge. But the 5 basic things we do is, number 1, we're going to sharpen it, bring it to a true cylinder. We want all the blades straight, okay? You can't have a blade that has got a barrel shape or a football shape to it. Each blade has just got to be straight. Fourth thing we do is we want everything parallel. So we want the rollers parallel to each other. We want the rollers parallel to the center line of the shaft. And the bed knife has to be parallel. So when you do reel to bed knife, you've got 2 straight surfaces. When we grind a bed knife, we're also grinding that top face of the bed knife at the right angle and straight. We don't want any dips in it. Okay? And the 5th thing we're going to do is put relief on it. So 5 things. We're going to sharpen, cylinder grind it, blades have got to be straight, everything will be parallel at the end of the process, and do relief grind if we want to. The whole basic concept of a cutting unit is it's a 90-degree box construction. Rollers, reels parallel, end frames parallel, rollers perpendicular, so that's what we call factory specs. Okay. So let's get to what we're doing here, and this is, I'm going to go back to how we made it. We mill these surfaces on a huge boring mill. After we mill those surfaces, we rejig and retool everything, and then we line bore all the holes. So for the track shafts and all the fixtures that are attached to it. So in our grinder, when we're done, we have a single infeed, and the stone or the shaft is going to travel parallel to the top surfaces. So how do we do that? And we were just checking this. There's no flex in this table because it's 3/8 plate steel. Let me get this. You can't see it, but we'll just, and what we do is we'll zero one side out, and we'll bring it over. Hit the other side, and we are off a whole bunch on this one. We were only 3.5 thousandths before.
It's magic.
Yeah.
this.
So, point being is, these rails are hardened, polished, and then hard nickel plated. And we'll set them up with a dial indicator. If one's higher or lower, then we'll shim underneath. Okay? Do the same on the front. And when I go out to a customer that wants to do a retrain or something, the first thing I do is this. I'll check it, I'll zero it out. Do one side, then come over to the next. And see, the front is just it, and that's perfect, but you can see I put, last time I was here, put some foil. Makes a great 1,000th feeler gauge or shim. So anyway, end result is you can always bring this to 100% true parallel. I think I checked it before, I was a little farther back, and we were like 3 thousandths off, so it's close enough. We like to be dead net zero, 1 or 2 thousandths over 22 inches or 30 inches. It's nothing. But that's just going to give you a linear. Okay, the other thing we'll do is our rear fence is back here. And our rear fence is adjustable back and forth. It's also self-centering, as you can see. You tighten it up. You do this. And what we're doing is we're pushing here and we're moving it against these two. There's a stop down here and a stop there. So what we'll do, come on, I'm trying to hurry. I shouldn't. Okay. What we'll do here is this barrel is fixed, so it's mounted to this plate in the center, and you'll notice this is offset. And there is a detent position on it. If we pull this off, there's a little dimple hole there. Right in the center is a detent ball, which is a ball bearing that's set in a Allen head, more of a set screw. What that does is if we want to find a zero position, here it just fall right into place. So that's our starting point. So we're going to say that's going to be close. We like to get these within 2/1000ths of an inch if we can. Our tolerance on the back is within 10/1000ths from, if I zero this, I want to be within 10/1000ths because it'll change when I move because we're going to different surfaces. Why the big 10/1000ths difference? Your cutting units, we have control of parallel on the rollers up and down. So we can parallel them this way, but we have no control over parallel on the horizontal. In fact, if you set cutting heights and you set it at like 125 or whatever, and turn the roller, it'll fluctuate 3 or 4 thousandths. So, but the whole idea of grinding, especially on ours, we want to get close to zero tolerance, variation right from the get-go, because there's all sorts of variables. There's bench rollers, dinged rollers, and all this stuff adds up. It just keeps adding. There's 3,000, 1,000th here, 2,000ths here. We want to keep it all within 10,000ths on the total cutting unit. The difference between us and everybody else is we can measure and control the table and the travel. This has got a little bit of roughness. I can feel there's a tick in it. So you want to keep it clean and dry. The roller's clean. You never want to use WD-40 or petroleum-based products. Good petroleum-based products like WD-40 dries with a film, and it collects grinding dust, and now you've got pretty much a grinder. It'll accelerate the wear on the traveling bearings and on the track shafts. Okay, so now I'm going to get this, and we'll see what we are here. So we're going to zero this out. Here's my zero. Go from there, and just hold it. The rear fence is locked into place. Come over here. And we'll find the high point. Let's go over here. Try it all over again. Yep, I was on 0. Bring it over here, and there's a difference of, let's see, 21 thousandths. So I'll find the high point there, and what I would do is,
Just this here.
we only use that one barrel, or this adjustable barrel once, and that's why when we're relief grinding. And what this does is after we spin grind, you got 20-30 thousandths to play with fore and back and alignment with the stone. But when we relief grind, to get an even grind all the way across, to even up our land area surface, by doing this, we fine align the center line of the reel shaft to the travel stone. So if we're grinding on one side and not the other, we'll make a slight adjustment. And I'm talking about that much. That's not very much at all. But I'm going to adjust that. There. So loosen this up. Loosen this side up. And we're just going to change the position of that. So what I'm going to do is go one way or the other and tighten it up. So that goes this way. I'm going to go right there. Tighten that up. When we do to one side, sometimes it affects the other side. See, it moved a little bit, and I may have bumped it. We'll zero that out. Very close to it. Carefully come to this side, and we're within half a thou. That's the easy part. The hard part is when you tighten this up, it'll move it. But my tolerance is within 10. I'm good to go. So, anytime you see a handle like this on our machine, it's should be spring loaded. So it'll pop up and it'll ratchet it. Okay. The only other adjustment we have, and I'm not going to worry about it right now, is I'll go off of the shaft itself, the alignment of the shaft in both planes, horizontal and vertical. The shaft is tapered, set screw on the stone goes here. This is the surface that we're worried about, and we want close to 0 as we can. But the tolerance is within 0.03 of an inch, which we have, so I'm not going to mess with it. Just be aware that we can take the tower and move it side to side, or we can move it laterally. There's adjustments on there. Okay. since we started designing the 2000, I mean, my boss bought the company, I think, 15 years ago. The operation of the machine 15 years ago is exactly the same as what it is today. So the nice thing about our machine is that we've made a lot of changes, a lot of small stuff that you can't even see, but we can upgrade the original machines to current production. So, and that was one of his design criteria. One of the complaints was, geez, you buy mowers are the same way. The 1996 model, the 2000 model, totally different, so now what do I do? Well, if you've got a 15-year-old machine, you can convert it and add all the features and options of today's production. Okay. And when I get done, you guys will be so baffled, you go, what the heck did he say?
That's why we recorded it.
It's like deer in the headlights, like, what are you doing?
It's all recorded.
I don't recommend this, but I've been in the turf business since 1978, selling grinders, using grinders, and then when things happen in the industry, so I wound up with my own company, and a friend of mine was the factory rep for Peerless at the time, so I rode with him and set up demos and everything, and I'm like you guys, I'm sitting there watching, I'm going, what is he doing that for? I have no friggin' idea. So after about 5 or 6 demos, man, I gotta learn this stuff. Sat in my office with a 12-pack of beer, ran the video. It was a continuous loop thing. I sat there for maybe 1 beer. Over and over and over, and a light bulb goes on. Oh, that's what he's talking about. Oh, yeah. So nobody ever gets it the first time. First reel we do will take this much time, second reel that, third, fourth, and it just keeps getting faster and faster. So, we're going to take a cutting unit. Where are we?
On there.
Right there. Just turn it quickly. Our pie tape, this has been buggered up, but that's fine, it's still readable. This is our pie tape, PI tape. Pi is the numerical formula, pi r squared, 2 pi r. This is copied after a machinist tape. It's made out of mylar. It's non-elastic. It may stretch, but it's not going to relax back. Wrap it around the circumference, doing a calculation, it's going to give us a diameter readout. Okay? And what we're interested in is, remember, we've got to take the cone out of the reel. The reason we do that is at some point in time, if the reel gets too coned, you lose your bed knife adjustment. The bed knife on this is adjustable up to the reel. So if you've got a 30 thousandths cone, bed knife will come up and it'll touch the large end. And then how do you get this end up? Man, you gotta crank it up, but this one won't go up anymore. So you end up tweaking that bed knife. The more you tweak it, the more it holds its shape. There's about 10 thousandths of actual flex or twist in the bed knife to where that's your tolerance there is 10 thousandths. So we have 10 thousandths to play with, of being perfectly parallel and straight. The other thing the 3 things we're concerned about. The other thing is the diameter of the reel. Jake, John Deere, Toro, they've all got the same specs. 5-inch diameter reel, 22 inches wide. The useful wear limit is down to 4.5 inches. So we only got a 1/2 inch of wear off the diameter that we can.
It's a 1/4 inch off here.
Yeah.
Each blade.
So it's not much. You can still use it, you can still grind it. You may not be, when it gets down to 4.5 inches, you can probably spin grind it. The limiting factor is being able to bring the bed knife up to the reel and get your adjustment. But as the reel wears, this is a bed knife to reel adjustment. You guys know about attitude and attack angle of the bed knife. Affects the aggressiveness. If I got a triplex more, I want about the same diameter on all three reels. If I get a new reel on the right front and one that's 4.3 inches on the left front, my attitude of the bed knife on the right side is here, and the attitude on the left side is up like this. It'll cut grass, but you'll see an after cut appearance, a different color in that pattern, which you don't want, because that means, well, something's wrong with the greens, So we're gonna measure the reel. Number one is find out how big it is and how much life we have back in it. We're gonna find out if it's coned or not, and if so, by how much. And then during our setup process, because this is a fixed surface plate, we're going to make all our adjustments that the manufacturers give you. And that is, we have a fixed front roller with an eccentric adjustment on this end, which means I've got the ability to move that one end up or down probably 20 thousandths or so. So I can parallel that roller. This back reel is an adjustable reel. That's where we set our height to cut. Adjustment back and or up and down on both sides. The reel is fixed. So the terminology is fixed roller with an eccentric, a fixed reel. Some, like the ESP reels, have an adjustable reel to fixed bed knife, and the rear roller can either be fixed with an eccentric or adjustable rear roller. Our process is identical from reel to reel to reel, manufacturer to manufacturer. It's the same basic process, but you got to know how the reel adjusts in order to make it work. Jacobson products have, like their Greensmore reels, has a fixed rear roller, a fixed reel, and adjustable front roller. So all you can do is put it on there, and that's it. There is no adjustment. We're gonna get into taking rock out and checking for corner to corner rock. If the front rails and the rear rails are in the same plane, then we're going to set the front roller and rear roller parallel to each other. But we're going to use one or the other roller or both to parallel the reel shaft to the travel of the stone. Okay, back to the pie tape. So what we've got is we've got two scales. On the left is the vernier scale. On your, my left. Called a vernier scale. It's nothing new. Calipers use a vernier. I don't know if you've got verniers. It's like 1500 AD. Some whiz-bang brainiac came up with this. Each line on the vernier scale is worth 1,000th of an inch, from 0 to 25 thousandths, 0.025. The scale on my right is an inch scale. Each one of these lines, the value is 25 thousandths. So we're going to wrap the tape around the reel using the magnet. And what we want to do is we want this side of the inch scale to line up exactly with that black line on the vernier. In other words, I don't want it at an angle. I don't want to bury it in the numbers. I want the tape to be in line as close to that black line, covering that black line as I can. Because to read the vernier, first of all, when we read our height, let's say it's a 5-inch diameter reel, so we wrap it around the reel. Our 0 is the start-stop point, and we're going to read the last line above the 0 on the inch scale. In this case, let's say it's a 5-inch diameter reel. Okay, it's wore down a little bit. The last line above the 0 is, here's our 4, and then there's 1/10 or 100,000s, 200,000s, 300,000s come on down the line. And in this case, the last line above the zero there's our 0.700. The last line above the zero is 725 thousandths. Okay? And that's all we can read there. So now what's going to happen, we're going to take a reading on the vernier scale and add that reading, 0 to 25 thousandths, to our inch scale reading. So in this case, it's like 725 thousandths. One line on the inch scale will line up perfectly with the value on the vernier scale. I've got a handout that goes through all this, so don't get too anal about it yet.
And we went through a lot of that with the calipers in our 4-stroke class.
Yeah.
And stuff, so.
Yeah, it's the same thing.
Yeah.
In this case, it's 7 thousandths. And this line over here lines up with the 7 thousandths, so 725 plus 7 is 732. So our diameter is 4 inches, 732 thousandths. Okay. What I'm going to do is mount this thing. Take this down so I don't hit anything. If you line up this pulley with the outside of that rail, see if I can get it in there. Oh yeah, it's going to be right on the mark. Oh, all bad. These 22-inch reels are light enough. Most of the young guys, not me, just pick it up and throw it on there and you're good to go. When we buy this lift, we modified the front. We have 3 rails. As you can see, they fit right in there. The notch is where the middle bar goes through. Bring it up. So you get it down to there. You can lower it. Not that hard. Oh. Let's do this first. Let's get it up. Roll the cutting unit back here. And then lower it. Let's get, no. Just leave it there. I want it on the rails right now.
Yeah, this one looks like you're hitting the
Yeah,
yard.
if you pull it forward,
Oh, it drops off
the fence isn't latched, so you can just keep pulling it back and it's going to drop down.
Oh, I see.
So let's do this. Let's just square it up.
Okay.
No, that's fine. Now you know. And I'll get this out of the way because we don't need it anymore. Take it off. And I'm just going to go through it real quick. Right there. Okay, cutting units on the table. What I'm going to do is I want to line the center of the stone up with the center of the reel. I want to be pretty much right over the center or just a little back. It doesn't matter. Not close, which is fine. It's not going to change a thing. Then I'll bring my rear fence up. But the problem with that is I'm hitting this rear roller cleaning brush. What did I do? That little box. I must not have brought it. They're 1, 2, 3 blocks. Little block. It's a little box. I guess I didn't bring it in.
Intermission?
Intermission, yeah.